For the initial setup of this lab, first thing you're going to do is set your cart and your tracks on your table. The track, when you set it up, you want to make extra sure that things are level here. So to do that, you're going to put the cart on your track. If the cart stays still, then you know it's level. If it slides one way or the other, then it's not. The two collisions we're going to look at are elastic and inelastic. So elastic is where they're bouncing off of each other. But we don't want these things to actually make contact, so what we have is magnets in the bumpers of the carts. So it's very important that when you pick your carts, you look at the letters on the side of the cart. For example, I have B and B, so you want a set with the same letters. On those carts, there's magnetic bumpers on one end, and that's what you're going to be using for your elastic collision. So that way they don't actually hit, and we don't lose any energy that way ideally. So you're going to set one cart in the middle, one cart at the end. You're going to set up video physics. I would actually suggest you use your camera first. Take the video with your camera and then import it into video physics. It'll be a lot easier for this lab. So you're going to take this cart, push it, it's going to collide with that cart's going to move, and then you can analyze the data for how fast they're moving before and after. For your inelastic collision where they're sticking, if you flip the carts around, there are Velcro bumpers on the other sides. And so that's going to be our inelastic where they're sticking together. So again, you start with one at rest, push this one, and then stick together, and you can analyze before and after, which we'll go over here in just a minute. Once you bring your video over into video physics, you're going to do a couple things. First, you're going to plot your points. Now, you don't need to plot the points for the whole video. Really, you're just looking at this area here where the collision is going to occur. So you just need a couple points here where things are moving good before the collision, and a couple points here where things are moving good after the collision. And that's for both collisions. And you can do that all on one video, and then export it and do the analysis. But before you do that, it's very important that we set our scale. The way you're going to do that, if you take your cart that's sitting still, the length of the cart is approximately 16 centimeters, so 0.16 meters. So you can set your scale that way. The origin, it's good if you bring this up so that your x-axis is right in line with your carts. It makes the analysis a little bit easier. And you can actually, if you put your finger on the little x here, you can rotate it this way and that way. And that makes sure that the x-axis is all in line with these carts. Once you do that, you can hit the button in the top right here. And the button in the top right, not the graph, but the send in, open it in a data file, and send it over to graphical analysis. For an elastic collision, when you bring it over into graphical analysis, ideally it looks something like this. We're interested in this line here, since that's where the carts are actually moving. This is our y-axis where there's a little bit of stuff, but that's just because not everything's perfect here. On the other axis here, or our other graph, we have, this is going to be the velocity before the collision and the velocity after. So those are the two numbers that you need for your chart. Now the other number it asks for, right, this is velocity of cart 2 after the collision for our elastic. Cart 1, you can make the assumption that it stops and is at 0. So you're going to highlight this section, and get your average values. When you do that, it should look like this, and you're taking the mean values here for each section. On my graph, both of these are negative just because of the way my scale was set when I did this experiment. You can make it positive since that's just a directional quantity. For your inelastic collision where they're sticking together, you should see a point where the first cart is moving with a higher velocity. Then they're going to collide, and they're going to move off together at a lower velocity. So this is velocity of both cart 1 and 2 after the collision since they're moving at the same speed. And this is velocity of cart 1 before the collision. So again, you're going to take the mean values here. So 0.392 would be your velocity of cart 1 before. 0.172 meters per second would be your velocity of cart 1 and 2 after the collision. So then you're going to take all those values, put them in your charts. You're going to calculate your momentum before and after the collision for each case. You're also going to calculate kinetic energy before and after for each case, and then answer the conclusion questions. I don't need copies of these graphs in the lab because all we're doing is just getting the mean values from them.